Hello everyone. So we will be heading towards our next lesson, that is the impedance triangle. Now what is impedance triangle? Let me explain you that. So impedance triangle, we have already seen that the various properties or characteristics of RL circuit, RC circuit and RLC circuit has been expressed using the phasors. Now that phasor can be alternatively also can be expressed in a triangular form. In a triangular form, we can also express the various characteristics of these types of AC circuits, and the impedance can be found using the Pythagoras theorem, which you already know what is it. Now generally the format for that impedance triangle is like this, that is the resistance, which is a real part is expressed in the x-axis. So in the horizontal direction we will assume there is the resistance, and since any type of reactance will always be in the y-axis, be it inductive or capacitive, so that will be perpendicular to the resistance. The reactive part will always be in the vertical direction. So these are two vectors. The resistance will be one vector along the horizontal direction, and the reactance will be another vector in the vertical direction. So using Pythagoras theorem, we have to find the hypotenuse. That hypotenuse will give us the total impedance of the circuit. That means this hypotenuse we have to find out. Now this is the impedance, how we are finding out the impedance triangle for RL circuits. As we already know that how the phasor diagram for RL circuit will look like. The voltage will always lead, the resistor voltage and current will always be in the same phase, and the inductor voltage will be 90-degree leading the current or the resistor voltage, and Vs is the final voltage that we are getting. So this is the phasor diagram. Correspondingly, we are drawing the phasor triangle or the impedance triangle for that, using the voltages as VR in the horizontal direction, since it is given in the x-axis in the x-axis in the phasor diagram, so it will be in the horizontal direction, and VL, that is the inductor voltage, is in the complex axis or y-axis, so it is in the vertical direction. So in the triangle it will be pointed as in the vertical direction. And finally the final voltage, the resultant voltage, is Vs, which is along the hypotenuse of the triangle. Now since these voltages are always directly proportional to their corresponding impedances, so we can express these voltage levels using the impedances. Now the resistance has the impedance of R, so that's why R will be in the horizontal direction, and the inductive reactance, which we know as the impedance of the inductor, that will be given by XL, which is in the vertical direction, and finally Z, the resultant impedance, is given in the hypotenuse. Similarly, we can find this for RC circuit. As we can see in the RC circuit, the capacitor voltage lags the current or the resistor voltage by 90-degree, so that's why it will be in the downward direction, but it will be again a vertical one. And this is for RLC, where we are calculating the voltage for VR and the resultant of the two reactances VL minus VC. So if we are calculating this for VL minus VC, so for inductor we are getting the impedance as XL, and for capacitor we are getting the impedance as XC. So that will in the impedance triangle it will be termed as XL minus of XC. In this way we can find out the resultant. Thank you.